Sorry?
Oh, yeah, I was asking.
Okay.
Hi everyone, welcome to the CCRMA Colloquium. Today we're very honored to invite Professor Andrew Schloss from University of Victoria, who is also our CCRMA alum. He is well known as a performer and virtuoso at the radiodrum. Today he's going to present the history of the radiodrum. Let's welcome.
Okay, thank you. Thanks, everybody. I see some friends from way back in the 70s, Julius and Chris and Dana and I don't know who else, yeah. Back from the early days, you know, I'm still teaching as I see Chris and Julius still are. And the students have no idea what it was like back in 1978. I mean, that's like, might as well be 1778. Anyway, in some ways. All right, so, you know, it's funny, I've been doing this since, actually not when I was at CCRMA, I was here from 78 to 85, and one thing that is interesting looking back on the history of electronic computer music is that CCRMA, which was on the cutting edge, clearly, in the world of electronic music, was still subject to the rules of technology. That is to say, we really couldn't do anything much in real time. Back at that time, we were doing all kinds of research that was fabulous and has pushed the whole discipline ahead, the whole art ahead. But we really we just couldn't concentrate on performance. So even though the Samson box was a real-time device, and we did do some live concerts, but they were only technically live. We were running a cable out from the machine room into the Samson box, or from the Samson box out into the concert hall. So it was a live digital stream of audio, but it was playing from files. So it was sort of like tape music. Anyway, I started out as a drummer way back in my youth, and I had been playing a lot in New York before I came to CCRMA, and I didn't do that while I was here because it was impossible. So I didn't work on that. So then after I finished in 85, I got my first job, which was at Brown University, which was a lot closer to Bell Labs than Palo Alto. And Max was still working there then, Max Mathews. So anyway, I went down to see him. I was very intimidated back in 1980 something. Way before I got to know him like we all did here. It was a whole different story. But at first, anyway, I got up my courage, I went to Bell Labs, and I met him and Bob Boie, and they showed me this really interesting 3D controller, and I was extremely interested in it. I really didn't know what you could do with it, but neither did they. I mean, no one did. Bob Boie was a master of, whoops, that's in the wrong place. A master of capacitive sensing, and he had done a lot of the very early work in capacitive sensing on touch screens and stuff, a lot of the things that ended up on smartphones. An interesting little story is that not too long ago, because I have been in touch with Bob Boie. He moved to a farm in Vermont after he left Bell Labs, and he told me that he was forced to testify as an expert witness in the defense of Apple, and he didn't want to do it, but I guess they made him do it. But anyway, and I might have this story slightly wrong. I forgot. I'm broadcast here, but so excuse me, Bob, if you ever see this. As far as I know, he wasn't interested in doing it, but anyway, he did it. And what was interesting was the defense was very simple. It was someone accused Apple of stealing their technology for, you know, the iPhone, which was, of course, worth a fortune. And Bowie simply said, "Look, I worked on this stuff back in the '80s," and that was the end of it. You know, it clearly wasn't stolen from Apple because Bowie had been doing it for decades. Things like that. Now, he never was able to commercialize it that much for various reasons. He also made a clipboard that you could write on, and it would then show up on your computer screen. All this stuff that at the time was pretty amazing. Anyway, so Bowie was in robotics, and Max was in whatever he wanted to be in. Max and John Pierce, sorry, who is famous for a lot of things, including naming the transistor. When he walked in the room and Shockley showed him, he said, "You should call that a transistor." So anyway, they were able to they were so senior that they could experiment with music and other things. So I don't have to tell you about Max because he was here for many years. But I will say that that Bowie's capacitive technology, there was a little bit of a question of what to do with it. So Max decided maybe you could make a three-dimensional drum out of it. And this slide is out of order, but it's a forward reference to a new version of the drum that no one has seen before, because I just brought it down today. And I'll show you this again later. It's hard to see on the desk here, so that's why I wanted to let you see it. For those of you who are technical, I'll bring this slide up again later, and you can also come up and look at it at the end of the talk, because it's kind of interesting. It makes this technology suddenly affordable for anybody to make their own drum, which we'll get to. Just while I'm talking about history, I can't help putting this picture up because it's so mind-boggling in terms of the history. It just blows my mind. I don't really belong there, but I'm happy I'm there. Well, thank you. I mean, you know. So David and I did a piece at the concert, the Centennial for Stanford University, when I think it was Paul Lansky and John Chowning brought theremin to Stanford, and he played the theremin. He was amazing. And that's in the documentary that's fantastic, that I really recommend. I don't remember the name of it, but you can find it. It's a documentary that was filmed by Steve Martin? Yeah.
Musical Odyssey.
Yeah, great documentary, and some of it was filmed up here too. Anyway, if you look at all these people, you just can't believe it. The most recent person we lost was Don Buchla, and there was a big event for him last weekend. Did anybody go to that?
Yeah.
Yeah, I couldn't go. So that's a little history. So now we come to what I've been doing. So basically at Stanford, you know, I did what everyone else was doing, or tried to do my own thing, which had to do with percussion, had to do with automatic transcription and stuff like that. And it didn't have to do with performance. But interestingly enough, Max was so far ahead of his time that he and I think Dick Moore worked on some kind of real-time stuff in the 60s, way before it was really practical. So, and Max had a lot of interesting ideas that turned out to be everywhere. Like, for example, the whole Guitar Hero idea is really based on his sequential drum concept, although it may not be directly. That is to say, they may have come up with it independently. But Max thought of this idea of putting music into memory and triggering it step by step with some device. And that's what he did with the radio drum, radio baton. So I'll come back to that in a second, just the three influences. And then Trimpin I met maybe 20 years ago through David Freck, actually, I think, didn't you introduce me to? Yeah. So, and David Freck was a student of mine at Brown, so it's a small world. Anyway, Trimpin kind of amazed me, and for a long time I was just a fan and just a spectator, and slowly I realized that what Trimpin was doing in art galleries, which was totally new to me at the time, I'm talking 20 years ago, before people had even seen a solenoid other than one inside of a printer or something. So Trimpin was doing all these fantastic sculptures, and he was playing them from little MIDI memory boxes, because he, you know, as an artist with a very practical mindset, he didn't want anything to break in the art gallery. So Trimpin would go around the world setting up these fantastic acoustic sculptures, and there's also a movie about him called The Sound of Invention, which I recommend. And anyway, he was reading from these MIDI files, and you know, the more I played this radio drum, the more interested I was in just unplugging the memory and plugging in the drum. And that's where the sort of subtitle of this talk comes from, which is the art installation as a musical instrument. I mean, why not play live into his installations? And I didn't know him that well at first, by definition, when I first met him. So I didn't dare ask him, but after a while he warmed up to it, and the first thing I did, which I'll show you a little bit of, was this piece for 8 robotic turntables, which were actually made from ceramicists' pottery wheels. And I found 8 copies of Jane Fonda's workout record and put all 8 on different turntables. And it really is amazing what you can do with 8 turntables, computer controlled. Anyway, and the last one is Henry Brandt, who David Jaffe, who is here somewhere, I think, unless he's still working. Yeah. David was one of Henry's most brilliant students. And Henry influenced both of us. And one of Henry's many contributions to modern music, 20th century music, was the idea of spatial music, the idea of spreading out the performers. And it sounds, you know, it doesn't sound as profound as it really is. When you start experimenting with space, it's really incredible. Things like rhythm, for example. I'm a drummer, and if you separate, that's why, again, I'll get to this a little later, but the robotics situation, if you have arms that are 30 feet long, so I can play a drum over in the corner and another drum over in that corner, because there's space, there's some space between them, it allows you to do different kinds of source separation that you can't do if there's 2 instruments right next to each other. I mean, if they're too far away, that's a different problem because of the delay of 1 foot per millisecond. But if they're reasonably far away but not too far away, you can get all kinds of really interesting patterns going that, you know, wouldn't be that interesting if you just played them right next to each other. But when you separate them, and when you use space as a parameter, it's very powerful. So anyway, okay, let's keep going here. So this is a little history of Bowie. In passing, I should say that I suppose I probably know more about the history of the radiodrum than anyone else, I guess, at this point. And there are many of them. The first one was the one that he gave me back in 1988, and I still have it. And it was a RS-232 9600 baud box with an antenna that looked like a tea tray. It was a white Formica antenna. And sticks that looked something like this, very sort of homemade. And this is just copper on the end. So anyway, they gave me the drum, and it was based on the same capacitive sensing idea that Bowie had been working with. There's something called the capacitive moment that allows you to basically figure out where something is in space. Now, it's clear that if you're talking just about the signal strength, it's very obvious that you can easily see how far it is, because that's just the signal strength which drops off as you go up. And infinity is unfortunately not that far away. This is about as far as you can go. But we'll get to that later. In any case, capacitive moment allows you to compute x and y. And let me take a quick diversion to show you what happens with capacitive sensing. So here we have a drum that Bowie made. This is the only one in existence. What happened was, through this history of drums that I was telling you about, they started with that one at Bell Labs, and then any of you who are here in the 80s and 90s know that Max and Tom Oberheim made a whole bunch of drums, but they weren't really drums, they were kind of radio batons. And I had a different goal being a drummer. I wanted to really be able to play it, and that's why I diverged from Max and tried to do my own thing. Of course, I'm not that technical, so I had a lot of help. What happened was, David and I worked on reprogramming a lot of Max's drums that were MIDI devices. But then I had a student who decided that you could make a drum from scratch in a way that I'll get to later, because I don't want to get too bogged down here in this part of the demonstration. Let me just say that when you're trying to sense the position of the stick, you have two different radio frequencies coming off, or two different frequencies coming off the stick, about 100 kilohertz and 120 kilohertz. And now you can see that it's, I can go on the surface here, and it's quite good. But as I go up, there's a problem with capacitive sensing. The capacitive moment that I was talking about a minute earlier doesn't work when you get up high. So if I move the stick up, see how it converges sort of in the center. And that's a physical problem that you can't avoid. So down here, it's super accurate. And up here, it's less accurate in X and Y. But it has a lot of advantages, which I hope I'll have time to tell you about.
I used to call that 2.5 dimensional.
Yeah, it's 2.5 dimensional is a good way of thinking of it. Now here's the thing, Bowie was already living in Vermont, and I did a concert at McGill, which was, I don't know if anyone was at that concert, but it was sort of one of these little think tank things. I remember Miller Puckett was there, and I don't know who else was there from the United States, but I did a concert with this crazy apparatus because I was trying so hard to make the thing into a drum instead of a baton. So I wanted really, fast responses that I just couldn't get with MIDI and with the stuff that Max was doing. You'll notice this still has wires. Max and Tom got rid of the wires, which was a great step forward, but unfortunately that made the sticks kind of funny, and I wanted to have a real instrument. So I kind of had a slightly different goal. But Bowie saw the mess that I was in, and he just, out of the goodness of his heart, built this drum for me, and it's the only one. This is an entirely analog drum. There's nothing digital in this thing at all. And you might wonder, how in the world does it even talk to the computer? And the answer is analog. So let me just let you read that slide for a second. So what happens here is that Bowie uses his expertise in analog engineering, builds a gesture sensor, which basically detects, you might say, the signal strength to the four corners, essentially, of the surface. So the surface is an antenna, and if you look at the printed circuit, you can see it looks like a backgammon board. And then there's some circuitry inside, and I have the circuit stuff, the diagrams and everything that he gave me after he built this. So let's see. So how does it communicate with the computer? Well, Bowie is an analog engineer, and he didn't want to do Ethernet. He didn't want to deal with USB. He didn't want to deal with Firewire. Thunderbolt didn't exist yet. And so he said, let's just use audio to communicate. So what we do, since the average audio interface doesn't go down to 0 hertz, the average audio interface goes down to, I don't know, 10 hertz maybe. Because why would you want to go down to DC? It's just not music. But if I do something like this, if I go back here again, whoops, this effectively is DC. I mean, this is such a slow motion compared to musical sound. So a audio interface can't read that. So what he did was he basically had us in Max send a sinusoid out into this, and then that sinusoid at whatever frequency you want, you just pick a frequency, you multiply that by the analog, in the analog domain, by this gesture voltage, and then you can digitize it, because then it's an amplitude modulated sinusoid at, say, 5 kilohertz. So you digitize it then in a standard audio interface. Then you have to demodulate it, which is pretty basic stuff, and that I do in Max. So this is a drum that's completely analog and that's future-proof in the sense that no matter what Apple comes up with or drops from their laptops, this will always communicate because it's just audio. So that's the good news. The bad news is I've tried twice to copy it and I have failed twice. I don't know. I've had some pretty good people helping me, and one person, for example, who's a very good engineer who helped Randy Jones with the sound plane, which you may have heard of. The sound plane is a pressure-sensitive instrument, very beautiful, that also uses capacitance. Anyway, he helped me. I think Brian Willoughby is his name. He helped me. We went from the schematics. It was a second attempt, and we got very close, but it just didn't quite work, and I can't find people who, who know about analog circuitry. So that's what led to the software radio drum that I'm going to show you as well. So of course, if this is an analog signal, you can set it to any sampling rate, and so on and so forth. Okay, so why am I using capacitance now? I mean, basically this instrument's been around for centuries in high-tech years. I mean, anything that's been around for 8 years is ancient, and so I've been doing this since the 80s. And first things like the Wii came out, and then the Kinect and the Leap and all these other sensors, and they were all mainly driven by gamers and that sort of world. And so it was heavily, very well funded and cheap, but they're not fast enough, like the Kinect, as an optical or video analyzing thing. So the frame rate of the video is not that fast. So basically, I'm still using this technology because it still works. So what's bad about it is that inverted bowl problem that you don't have with the Kinect. I mean, you can go like this with the Kinect and you'll get exactly within the accuracy of the Kinect, and you have this huge space. So I can't go that far, but I can do a lot within a few inches of the surface. So, okay. So now what do I do with this? I mean, a lot of this stuff isn't so new anymore. Of course, when I was doing it back in the 80s and 90s, no one else was doing that sort of thing. Now you can do it many ways, but it's still interesting to think of things like the fact that there's 2 different frequencies being transmitted from the sticks, so the drum knows which stick is which. And when they first showed me that back in 1988, I said, well, what are you going to do with that? Drums don't know which stick is which. Because I was thinking kind of in a very conventional way about percussion. Well, maybe drums don't know, but we're doing, electronic music. It's extremely useful to have a different signal coming from each stick. It can also know that it's about to be struck. It can be sort of looking up and seeing that the stick is coming towards it. I haven't really used that much, but there's a new actuator that we're building now that is going to be shown at NIME. Anybody going to NIME? Yeah, so Robert Van Ruyen is his name. He's going to give a demo of his new solenoid. Amazing. Unfortunately, he's trying to patent it. So yesterday he sent me an email and told me to block out the slide that I have for you. And then I said, yeah, but you're about to show it at NIME. He said, yeah, I have to file the patent before NIME, so I don't know how he's going to do that. Anyway, so the nice thing is if you have a solenoid over here that's mirroring what I'm doing, instead of MIDI where it goes all the way down and then sends a note on, and then this thing goes, oh, note on, and it's late always. What if it could actually mirror, move at the same rate as my hand? that would be great. Then it could anticipate the strike. So anyway, that's what we're working on. So I have all these funny modes with very scientific names. There's whack mode, of course. There's continuous mode, which is just moving in space. There's magic wand mode, which is funny. I'll demonstrate that. Basically what's happening is it's in continuous mode, but it's triggering at a constant rate, so you can play sounds at a very fast rate and change the dynamics and so on and so forth. It's hard to explain. I'll just demonstrate it. So, and then there's squish mode, which Randy came up with because he's working on the pressure sensing. And that is, you can push below the foam and get a whole other sort of response. And he was doing it with a mesh, like some kind of physical model with a mesh, and you can push down on the model in different places. Of course, if you have 10 fingers, you can do it with 10 fingers. But I can do that with this instrument in addition to all the other things. Now, it does have, as Matt said, 2.5 dimensions, because it doesn't really work all the way up here. But it has the continuous mode and the whack mode. Now, they're not orthogonal, obviously, because if you're going down here, you can't suddenly hit it over here. But it is useful to be able to play continuously and then every once in a while trigger something, which I'll be demonstrating that. This, I don't really need to show this, even though it's kind of fun, because you've all seen it, right? I'm sure you haven't seen this? I'll just play the beginning of it.
Revolutionizing all the fields that use computers, including computer music. One group that's leading the way is called CCRMA, which stands for the Computer Center for Research in Music and Acoustics. And tonight we'll meet some musicians and composers who are embracing these changes.
So that's the, oops, oh, sorry. That is, if I can, here we go. Okay. This is Max's tea tray. This white pad, it has Formica over the antenna, the printed circuit. And so this was a very original one, and it was a serial connection to a laptop or something. A big problem happened later, it happened to everybody, when USB replaced the RS-232 port. Nothing worked, MIDI didn't work, and everybody remembers that. It's sort of funny what happens to the piano here.
This is Andrew Schloss, but he's not a pianist, he's a percussionist.
Oops, okay. That's called blowing the fuse of the disc clavier. That was here at CCRMA. We've had so much trouble with these disc claviers because we're overdoing, they weren't designed to do what we do. And what's weird is that every single model is slightly different. We did a concert here a while ago, and I checked with Chris to find out what model it was, and there was some slight difference, and it wouldn't play the same things that I was playing. So watch out if you're using a disc clavier. Julius is in here. This isn't about Julius, but there's Max. But where are you?
There's David.
There, yeah, there's David. Yeah. Oh shit! Sorry. I'm not used to this user interface. All right, I'm not gonna waste all the time of this talk on this, but let me just play a little bit of David and a little bit of Julius.
Careful to begin with a clear relationship and kind of bring the audience with us and say, well, he really is playing this.
In the early days of computer music, we found out very quickly that we had a problem with repetition.
Associate Professor Julius Smith is working with a team developing the synth builder, a device they say is the next generation synthesizer.
Instead of just recording the output of an instrument, instead of recording the sound it makes, we in a sense record the physical properties of the instrument. No two notes are ever exactly alike. They're like snowflakes.
They're like snowflakes. I like that. Okay. Okay. So yeah. So physical modeling. It's still, people are still developing that idea. That was another thing that came out. First FM, of course, with John Chowning, and then physical modeling was really important. Anyway, so now I'm just mentioning different versions of the drum. So here's the next version of the drum. Notice this is plexiglass. And there's a printed circuit under the plexiglass, and then there's a big, thick piece of plywood under that. You might wonder, why does this thing weigh 8 pounds? And the reason is that I didn't know what I was doing, and I had problems when I would hit the drum. I would get double triggers. And Max thought, well, maybe you're distorting the circuit board. Maybe that's why. So he made this incredible sort of bomb-proof antenna, and it turned out not to be the case, I don't think. I think it was just, we didn't have enough data, you know, there wasn't the algorithm to find that peak, or the change of direction, the acceleration, wasn't good enough, and so I was getting these extra hits, and so Max was very nice and made the antenna like that, but I still had the same problem. This was at Seamus in 2006. Anyway, so this is in Banff. I did a lot of work in Banff. I know Chris likes it there too. Nice hot tub. This is an article I forgot existed in an Italian journal called Strumenti Musicali, and there's the RS-232 connection, and the old Mac 2 and all that stuff, and there's the T tray. Now, one of the things that I did, you know, I did a lot of simple physical things. For example, Max's sticks were like this, and then he'd put balls of foam on them. And aside from the fact that they looked not that serious, to be fair, they also were hard to play for a drummer like me. You know, I wanted to be able to play really fast stuff like that. And so I switched. I put the foam on the drum. This foam was really hard to find. It turns out in the Jaffe in Paris, you know the Jaffe, that big department store, they had a basement upholstery store, and they sold this fantastic, this is not synthetic foam, and it feels great to play. And so I found that foam, and then I could never find it again. And it took a very long time, but I took the foam off the stick and put it on the surface. So I just kept doing these little things to make it more like an instrument. This is Trimpin with his guitar sculpture at the Experience Music Project. That's been renamed, I forget what it's called now. Paul Allen's originally his Jimi Hendrix, sorry? Bopop, yeah. This was, it's a funny story. Paul Allen had a Jimi Hendrix collection, and he really wanted to just make a Jimi Hendrix museum. And then some musicologist said, you know, you gotta go deeper. You gotta talk about what music is, where it came from, and so on. And that became the Experience Music Project. And they commissioned Trimpin to build this sculpture. It's cool. And Trimpin sculptures are fantastically beautiful, and they sound great, but they don't just sound great, they're really works of art. So you can imagine how fun it is to walk into this gallery and plug into these sculptures and start playing them. So I've been doing that over the past 10 years or so, and finally, most recently started curating concerts using his stuff. And he's very open-minded about it. There are plenty of artists who would just say, look, this is my art, get your hands off my art. But he really is interested and curious to see what other people do with it. So we've been doing that quite a bit. Trimpin and I and David just applied for a big grant called the Art Installation as a Musical Instrument from Canada Council, and we didn't get it, unfortunately. I just found that out, but we'll try again. So the robotics thing, you know, I don't have to sell this anymore. It's very popular, but so that's just some of the reasons that I think it's interesting. And of course, loudspeakers. You know, there's the old quote of Morton Feldman that Charles Amerkanian used: "Loudspeakers, tombstones." That's one of Feldman's quotes. Anyway, so what are the problems? The biggest problem is latency. You know, as I say, if you detect a hit, then you send a note on or something, or it could be OSC, it doesn't really matter. And then the solenoid goes like this. Now, of course, I'm playing samples here, so I don't have such a big problem. But if I were playing a sculpture, you would see the thing go like this after I hit it. And it doesn't matter if you're playing from a memory, you know, like a file, because of course you can't see the bits flowing down the wire, so it seems like it's in time. So that's how sequencers work, and other things that deal with, like the piano. It has a 500 millisecond delay, and it looks ahead, and it just fixes the latency depending on how fast the key is moving. And humans do that too. If you're playing the piano and you're going to play a loud note that speaks very quickly, you can start later than if you're playing a slow note. You have to start very early. But you can't do that when you're talking to a solenoid. Anyway, okay. So the very first one that I did, this is Trimpin Studio in Seattle, which is a wonderful place to go. It's fantasy land. The first thing I did, he had a piece called Clavier Nanette, which is 9 high-end toy pianos with solenoids in them. And he had it set up at the Jack Straw Gallery with a kind of a coin-operated thing where you could play John Cage, you could play different pieces that were written for it, and it was fun. And the thing was jammed with quarters. It was very popular. That was the only thing that went wrong with it, was it got jammed with quarters. So anyway, I finally convinced him to plug into it, and I did this performance at Jack Straw. So there's one of the pianos there. There's 9 of them spread out. And this looks like the original drum when I put some wetsuit foam on it. So I'm just going to play a little bit of this so you can hear the sound of 9 toy pianos. So I'm sorry I can't play everything because we'd be here too long. And this is funny. This was at the Western Front in Vancouver before anyone knew that disclaviers even existed. So I'll just play the beginning of this. This is from David's piece called The Seven Wonders of the Ancient World, but it's just the piano cadenzas. So it's a cool piece. People just freaked out when they saw the piano being played live. Anyway, we've done that piece a lot. Okay, here's the piece for 8 potter's wheels, each one with an identical copy of Jane Fonda. So this sounds like electronic music. This does not sound like a record player. So it's a little longer than that, of course. Oh, now this is a nice piece. I think I have to skip it, though. This is called Uni. This is actually in Cuba. I'll play a little while I'm talking just so you can see it. Randy Jones and I have done a lot of work together. He's the guy who made the sound plane. He also made the alto and the Kaivo synthesizers, which are very nice. And at the time, we were exploring something that predated jitter. It was something called Anodyne that somebody in Seattle commissioned. It was a graphical programming language. A matrix language for video, live video. So we did this duo that was basically controlling sound and video simultaneously. But I'm sorry, I have to skip it. And then, okay, so I went to IRCOM in, I think, '88. Wessel was there, and he was doing lots of interesting work with small computers, which I was amazed he got away with, just because Boulez seemed like the opposite. You know, his interests seemed completely opposite of making technology accessible with personal computers. But Wessel was amazingly, charismatic and enthusiastic, and somehow managed to create this entire world at IRCOM that really wasn't Boulez's view of the aesthetic universe. Meanwhile, I took it way further and started rehearsing jazz secretly at night. I don't even know, people were not around when we did this. This is Jeff Gardner, who now lives in Brazil. He's a really good pianist. He was playing in some clubs in Paris, and I just went and saw him at New Morning or something and said, hey, let's try this. And he met this bass player, Youssef Boukela. It was pretty famous, I think, in Algeria. And we started just, jamming, and with whatever technology we had at the time. And then I kept doing that, and I really felt that, it's funny, those of you who made it to the Computer Music Conference in Havana in 2001, this is before that, but the reason I mention is that David Ziccarelli didn't make it because of the 9/11 disaster. Lots of people didn't make it, but some people did make it. And they got very angry because I had asked David Ziccarelli to give the keynote, but he wrote it down and sent it to someone else, read it. And what it said was basically, yeah, remember that? And people were really upset because he said, you know, this music, if you don't play it on a really good sound system, it's not worth listening to. Why is that? And he, you know, I thought it was a very interesting talk, but it was very critical of sort of timbre-based music, if timbre is the only parameter, you know, no rhythm, no whatever. It sounds reactionary, and some people thought it was reactionary. Anyway, in my own mind, it's not that I agreed 100% with David Ziccarelli, but I definitely had an idea that rhythm was important, and so I really wanted to show myself that I could play rhythmic music with this electronic stuff. And I tried as hard as I could, and you know, here I was trying to do Cuban music where the drummers are the best in the world. And I somehow convinced the best pianist in the world, or one of the best, Chucho, to jam with me at the UNEAC, which is the Unión de Escritores y Artistas de Cuba. It's a really nice artistic place where people go for concerts and so on. This picture is actually in Victoria, BC, but I'm going to play a little bit of this, and the sound is terrible, and I'm playing like a Roland sound canvas or something, so that's all I had. Oh yeah, so this is with better equipment, sorry, and a different pianist. This is Hilario Durán and Irene Mitre on violin, and this is at NYU. I forgot this picture was in here. And I, you know, slowly developing my arsenal, and I just remembered I have to hit play. Whoops. Hey, there we go. Okay, so here we are in Cuba at the UNEAC. This is a piece by Chucho. It's tricky rhythmically, which is why I asked him to play it. Pause it just for a second. Those of you who are interested in history, there's another version of Max's drum. That was the pizza box version, where all the electronics was inside. It had like 4 mica sides. And it was a MIDI, I think it was his first MIDI version of the drum. And it was a struggle for me to play this kind of music with it, but you know. That's Juan Blanco, who was sort of the Charles Ives of Cuba. Now I'm going to play just about 30 seconds at the end of a free improvisation I called Blind Data. It's funny just because, forgetting about electronics or anything, it's Chucho, this genius, trying to get me to say, you know what, we're done. And I was totally oblivious. And finally he came up with a solution. He'll just start fading out. So I think it's really funny to watch when I finally get it, that it's over. So this is called Blind Data. It's just the last 30 seconds. Oh, we're done. Okay. So.
It worked really well.
Yeah, it did. Well, yeah. Anyway.
It's either the end or a solo.
Yeah, exactly. So I'm going to play you, short excerpts of other things that we've done, and then I'll do some demo comparing these two drums. And also, I'm curious to hear from the technical people in the audience at the end of the talk what we might do to improve this other drum. But anyway, so this is I commissioned David to write a piece, a sort of structured improvisation, using all the ideas that we had been talking about, and using Afro-Cuban music stylistically. That's Hilario Durán, who used to be the arranger and pianist for Arturo Sandoval. He's a great musician, and he lives in Toronto. So this is called Underground Economy. This was at Town Hall in New York, and San Francisco. No, Seattle. Sorry. So this is magic wand mode, where I'm polling. I'll demonstrate this. And this is using continuous mode to, and I'll demonstrate this too, but David wrote a kind of interesting reverberator. And so what you can do is you can basically trigger the sound with one hand in the whack, and then control the DSP parameters with the other hand, or both hands, and you have 6 degrees of freedom to control different parameters. And so that's what's going on here. And I should say that I'm doing this with samples, but of course you can do it with real sounds in robotics too. And then another thing we've explored that's really fun for me is basically stealing notes from the piano, just using the piano bar or a disc clavier, and then recycling them in some complicated rhythmic and timbral ways. Let's see if I can find that. So that I'm actually not generating any of my own melodic material, but I'm recycling his melodic material. So I'm kind of like another brain processing the same melodic information. Oh, shit, sorry, I'm just not used to that. Oh, great.
Good work.
Okay.
I'm sure we'll get right on it.
Yeah, I'm sure too. Oh. Okay, let me go to there. And I just want to play this because it's very rich area of improvisation. Okay, somewhere out here. Yeah. Well, it's a little hard to tell. I'm going to have to go on, but anyway, that is something we've been doing a lot. This was here. I'll just play a little bit of this. Jovino Santos Neto, who's a Brazilian composer, pianist, teaches at Cornish in Seattle. was here a few years ago. And now here's a treat for you. This is one of the members of the audience who thought it was funny. Recognize that laugh? Okay. All right, back to, whoops. Sorry. Okay, so now we come to our most recent collaboration. This had to do with Charles Amercani and Henry Brandt, and it just converged somehow. It was something we wanted to do for a long time, and then we were able to get a grant from the Irvine Foundation. And so this is a piece for 2 string quartets and me as a soloist playing robotic percussion and piano. So this is pretty short. I'm just going to play the whole thing because I think it's kind of interesting. This is now the drum playing no samples, no synthesis, just controlling physical sounds. Of course, the piano. I just want to point out that infinity is somewhere out here, but if you get into the range where the signal is being picked up, you'll start to play sounds that you don't want to play. So I have to really exaggerate the fact that I'm out of range. And notice also when I'm doing a crescendo, the crescendo, nothing much happens from way up here until I get to about here, and then suddenly the crescendo really kicks in because of the way the signal strength is. Now the left hand is sort of fading it out as I go up. But see, I couldn't quite get out of, I couldn't quite stop it. There we go. A note on the chimes. Oh shit, sorry. The chimes were really an installation. They were hanging from the ceiling of the hall, and they were hanging above the audience. So I really enjoyed playing the chimes. Let's see if I can find that. Somewhere right about here, I guess. Here's a chime solo. Now the mapping on the surface of the drum is the same as the mapping on the ceiling. So you can, if you're listening to it, they kind of match and looking at it. The circular motion there will cause a circular motion in the ceiling. Anyway, that's called The Space Between Us. So here's the first, I'll just play a little bit of this. It's the first version of Trimpin's installations where I actually curated a concert as well as playing something. So Trimpin came to Victoria, we tore up a bunch of pianos that were headed for the dump, and then Trimpin made all these crazy actuators, and then each of us, composers and students of composition, wrote pieces for this installation. So this starts really quiet. Trimpin has this magnetic exciter, sort of like an EBO. So the singer was off stage getting the pitch before she came in, so she could sing the same pitch that I was about to excite on the piano. I hate to jump all around, but in the interest of time, there are lots of other kinds of sounds in here. Let's see. And so on. And then this is Trimpin's Vorsetzer. Interestingly, when I first saw this thing, I loved the look of it, and I was so frustrated with the disc clearer that I thought that this thing, which Trimpin built to perform Conla non Caro's incredibly complex music, I thought this would blow the disc clearer away. And it turned out, after we started using it, that it does blow the disc clearer away in speed, and also the fact that you can play way more than 16 notes at a time. But there are other things that it, is challenged to play really quietly, for example. This is in his studio. We're building two new Vorsetzers, I should say, hopefully with some better hardware and software. And David Freck is actually working on that one. Now here's a hybrid. Ajay Kapoor, who many of you know, who's at Cal Arts, he got his PhD in Victoria after he left Princeton studying with Perry Cook. And he was really into robotics. In fact, he sort of got us into robotics. So here's a case where we have 4 Indian drums and a bunch of other things that have microphones on them, so I can pick up the sounds of the physical drums, but I can also augment that with samples and other things. And of course, if you play too fast, the drums can't keep up, so you can do all kinds of interesting, you can play with that idea. So this is back to the triggering the samples, but you'll see that as I bring in the drums, at louder dynamics, the solenoids get enough voltage to play. So I'm not hitting the drum at all. The right hand controls the speed of the polling. And this is doing DSP on the drum sounds. So the wax trigger the actuator, and then the X, Y, and Z controls the DSP. Okay, and now this is a duo with violists from the Lafayette String Quartet. This again using the very simple actuators that are playing frame drums. And now here's the, this is covered up because of the patent problem, but I thought I could show you the drumstick. So this, whoever's going to NIME, check out this voice coil actuators for percussion robotics. This is really, really nice what's under here. You can't see, but check out the motion of the drumstick. You can continuously move it, and you get feedback from the stick, and you can play super fast also. That was X-rated. So yeah, the idea that, because it can track position, unlike the sort of trigger solenoids where you just bash them with a voltage, it'll be really interesting to see how it tracks along with me. We'll see. Now we get to the software-defined radio drum. So this is really cheap stuff that you can buy for $200. And I'm going to jump back to the picture of it for just 1 second, which I put erroneously at the very beginning. Here's what it looks like. So there's an FPGA board, and then there's this custom board, and these two on the lower left, or lower right, sorry, are the outputs to the sticks. And then the other four are the four corners of the antenna, so to speak. And so all you need, this is an Ethernet instrument, and you just plug it into an Ethernet port and go. So yeah, so I just wanted to show you a picture of that. Now let me jump ahead. Yeah, so let me see what time it is. I'm running out of time, so I'm just going to do two things here. I'm going to play a little bit of the public art stuff that I've done, and then I'm going to do a very quick demo, and then I'll open it to questions. Is it okay if I go slightly over? Yeah, okay. So this is collaborations I've done with visual artists, and I found that it's really a wonderful kind of collaboration because the visual artists, have this incredible expertise, but they don't necessarily know that much about time-based art, so it's fun to collaborate with them. So this was a proposal that I used the video for. This was a piece by Buster Simpson, a giant float out in the middle of the water that goes up and down very slowly with the tides. So I figured if we speed it up by a factor of 2 million, we'll be able to make sound from it. So that's what I did. Of course, we had to collect a year's worth of stuff to get the first 3 seconds of audio. There's the sculpture. And this, as far as I know, is on all the time. I haven't checked lately, but. So that floats and tilts when the tide comes in and goes out. And it has a little camera, and so it rotates, and each of these images is an image from a different time of day. And then the next one is a fiber optic sculpture.
Simulation is translated into the sculpture's visual component.
The beautiful sculpture.
The sound of the waves in nearby Puget Sound and other environmental sounds are translated by a computer into data that is sent to the illuminator controller via digital multiplex protocol, the National Oceanic and Atmospheric Administration.
This is in City Hall in Seattle. I'm not sure if it's still running. It's a problem with art like this. But it's big. It's a big sculpture. It goes all the way down this, like 5 flights of stairs. I think you're going to see how big it is. So it's very simple. The water sounds that I recorded are triggering and controlling the illuminators. just using FFTs and stuff like that. Then we made another version of it that was at the Japan Center in New York. This is a smaller version of it, but what's cool about this is that we put an accelerometer in a chair, so the faster you rock in the chair, the different waves sounds are triggered. So it kind of matches your motion. This is Nobuo Nagasawa. This was a very popular installation. Everybody wanted to sit in it. And then this is a library, and I was really interested in the rain, so I put a hydrophone on the roof and tried to amplify the sound of the rain in a different sort of modality from what we're used to. With lots of reverberation added to this. And then there were also a bunch of anemometers on the roof, so I used the PAF algorithm, Miller-Puckett's PAF algorithm, to basically create harmonics when the things are spinning faster. And I was surprised at how different each one was, even though they're on the same roof. There's like little microcurrents of air. This ran for a long time and then broke, and they never wanted to fix it, unfortunately. Again, public art. Sculptures are a lot easier. Just clean off the bird poop and they're done. And I also use samples from around the city. Okay, now let's go back here. We're almost done. Yeah, so this is the support I got, have gotten over the years. I've been in Canada, as most of you know, and Canada has been more generous, and especially who knows what's going to happen now. Some of you might want to flee to Canada, but let me know if you need a place to sleep. And we have a nice buchla there, which I almost got rid of because some guy kept faxing me from LA wanting to buy it, and some part of me said, you know, if he wants it so much, maybe I shouldn't sell it. So it wasn't, now everyone loves it. It's the most favorite instrument we have. So now let me just quickly demonstrate some of the radiodrum stuff. So here's the radiodrum, and as you know, the three-dimensional aspect of it. And so, you know, let's see. Let me bring up one other thing here. So, of course, you can figure out various things about it. If you want to play it more like a drum, then what you want to do is, for example, something where you know, where instead of, that's funny. Just a minute here. To figure out why that's not working. I think I know. Yeah, that's why. So you can obviously map it however you want. So in this case, though, sorry. There we go. So let me go back to that patch. So, you know, you always get this sound here. Now that's useful if you want to just play specific sounds in specific places. Of course, there's a lot more complex things you can do, but it's useful to have that. If you were just doing that, you might as well use a Yamaha drum set, except for one thing. You can make a sound here without that horrible noise that you hear when you play anything that's relying on impact. This is not relying on impact. This is just, detecting a change of direction. And then a couple other quick. Let's see. This one is one you heard already. So this controls the speed. And it looks like I've got a problem here with, I've got a problem with Z. See, it should go away. Oh, I think I know what's wrong. Sorry. I think it's this. I have to close this. Let me see if that fixed it. Yeah, okay, here we go. So, and you can go really fast if you hit it here. or here, it's very slow. Now what this allows you to do, if I, for example, want to do something quite rhythmic, I can do this. Let's see. Yeah. Yeah, okay, here. So now this is something kind of virtuosic. If I just have to play it faster, I can just go like this. That's ridiculously fast, but let's say I'm just a good percussionist, but not a robot. Maybe something like this. So it gives you some power, and being a drummer helps. I mean, I could give this to anybody in this room and they could do some interesting things with it. I think probably if you play percussion, you know, you can make it sound more the way you want to make it, but who knows? Now let me demonstrate, actually I'll just skip and go to the, this is from the piece that David and I did. So here's a timpani. It has pitch bend, that's not so interesting, but I can also do it this way. Now I'm controlling this strange reverberator. And if I bring the left stick down, it stops. And I can do that, you know, with other kinds of sounds like this. So it's nice to have that combination of continuous and discrete. Okay, so now just because we're over, I'm going to skip, except I'm going to show you the other drum. So let's take a look at this, which is now not working anymore because something went wrong. But if you remember what that looked like, if you can try, now I'm going to bring up the other drum, the little SDR thing, and show you what that looks like. So that is here. So here we have, if you know, getting a quick look at the patch. This is a UDP receive. If I turn this on, we start seeing numbers. I see a 0 here, which means that one of these flaky connectors isn't working, which is a drag because we won't be able to see much. So if you could see this, what you'd see is that it behaves a little differently. I'm hoping it will be just as good. It'll take me too long to fiddle with this to find the loose connection. But we just got this working yesterday, actually. And what happens is, I think it's because we're powering it with just USB, which is not a very much power. And this thing gets 15 plus or minus, so this is a 30-volt thing. So the signal is probably a lot stronger. I have not measured it. This signal starts to get very noisy right about here. I'm hoping that if we just give it a little more power, that this one will be as good as the other one. Yeah, one of the connections is broken, so you can't really see it. But, anyone who wants to come up and look at it, you're welcome to do that. So I think I should stop, but thank you for coming. Thanks. And come on up and, you know, say hi or take a look at this circuit if you want.
How about some questions?
Questions, of course. Sorry, questions. Yes. Thank you. Any questions? Yeah.
Andy, I noticed in your performances you just use one. Have you ever tried using multiple?
Yeah, good question. I can, well, if this one works, it'll be great because it's Ethernet, so I could network them. One of the problems might be, and I just don't even know yet because I've just started this, but I only have one of these, so I couldn't test that. But now that I have this other version that's quite cheap to make, I could definitely try that. Now, of course, you have to wonder how much interference there might be. So one could have, let's say, 150 kilohertz on this, 180 on this, 210 on another one, and theoretically that would be enough spread of bandwidth so that you wouldn't get interference, but I'm really not sure. One of the problems I had with other versions of the drum was that any kind of electromagnetic interference would cause terrible problems. We did a concert at Judson Church in New York, which is a really beautiful place to play, but it's really old, and I almost couldn't play. I had to run an extension cord from a different floor Another time we did a concert with Ajay, who had these big transformers or power supplies for his robots. And I was next to a power supply. I couldn't do anything. So luckily I figured out what it was and he just turned it off. But anyway, yeah, it'd be great to know how well that'll work, and I should be able to do that test in a few days, but I don't know yet. Yeah.
Looks like your Valley connector started working.
Whoa,
Yeah.
that's kind of crazy. Let's see if I can display. Oh yeah, that's weird. All right, now good. So now I can show you what it looks like. So it looks pretty good, you know, moving along the surface like this. But see, when I get up here, see how jittery that is? The other one was not so jittery when you got further away. And I'm assuming that's just signal to noise. It gets pretty calm when you're on the surface. I mean, it looks good for the first, you know, it's the first time we've done it. And it does pretty good detection of impact. I can turn that on, theoretically. Yeah, this is just a simple. So it's detecting pretty well. And so anyway, it's very promising. And anyone who wants to make one of these, like I say, it costs you about $200. It's very cheap. As opposed to this, which really no amount of money. I've spent thousands of dollars trying to copy this and I haven't succeeded. Any other questions? Yeah.
Have you measured the latency from like drum hit to sound?
Yeah, well there is a measure of latency here. Let me just show you. But this is not completely the same thing. But let me show you what we do. It's kind of funny. It's a patch that for this drum, when you turn on the DSP and then you click on this, it tells you how many samples latency there is, sending a click all the way around, and it says, verify. Okay, why is that? I'm glad that didn't happen before the demo. Let me just quickly try one thing here. Sometimes if I... Power cycle.
Measuring is the latency.
Right, it's not the whole latency.
Sending the sine
Right.
wave out of your computer to getting a new sine wave back into your computer.
Right.
Not the
That's right.
like time between when
That's
you
right.
physically hit the thing and when that.
You're right. So we have already 429 samples, which is 9 milliseconds or 10 milliseconds, just doing that loop. Then you have to add to that whatever else is going on. Yeah. It's still nice to know what the latency is. Now, what's a tolerable latency? I would say if the latency is absolutely steady, you can tolerate up to probably 20 milliseconds. If it's jittery, then, you know, lots of people have studied that. I can, you know, I'm pretty good at telling how much latency there is. I mean, up to a point. And this is pretty good. Where it really gets nasty is where you start using solenoids. The delay is horrendous. It's way worse than any of this stuff. So you just have to work on that, work with it. Any other questions?
You know, early on, Max had a version that was mechanical, right? With strain gauges.
Right.
Whack. I carted one of those around for a while.
Really? You know what? I never used that one. When was that, approximately?
82.
Oh, that was before I even met him. Okay.
Yeah.
Wow. Wait, no.
My decades get messed up.
Yeah, actually, I'm confused. Yeah, I was here in '82, but I didn't know him yet. He didn't come out here until, when did he?
Get that? Yeah, something. But
Anyway,
it was basically, it was, you know, mechanical. You depress something by hitting it.
Right.
And that was measured by this array of strain gauges.
Interesting.
And, it was a resistive bridge.
Uh-huh.
I guess so that means it was super fast.
It was probably really fast, but of course it didn't know anything about up here.
Right. And for my music, I mean, it was, you had to whack it, and that was kind of
That's what you...
belying the whole approach, you know. But yeah, then there was nothing above.
There's nothing above, but you got the advantage of having super fast response. Right? Yeah. And super reliable, I guess. Yeah.
Sort of.
Yeah, right. Yeah, the reliability problem, you know, like let's say you put your sticks on here and you go out to dinner. Assuming nobody bumps into it, it shouldn't ever misfire, you know. And so there's always this tweaking between having it misfire once every 2 hours and being able to play incredibly tiny strokes. And that's always a balance of any system with noise, you know. So I'm still working on that. The thing too is that if you're doing computer music, you know, one hit in a normal world would be one hit on a cymbaler. But in our world, one hit can play 5,000 notes. So, you know, you're screwed if that happens. Yeah.
Have you thought about pairing the capacitive technology with something that could do
Yes, I have thought of that, and that's definitely a good idea. I haven't done it because I'm stubborn, so I keep trying to get everything I can out of this. But yeah, why not use both sensing techniques? I haven't done that, so someone should try that. Yeah. Any other questions? Okay, well, thank you.
I have one question.
Yeah.
What do you think? Are other people carrying on the tradition? Are you disseminating this? Or?
Good question. Well, you know, it's funny. Over the years, people knew about the drum through Max, of course, through Richard Boulanger in Boston, and through me. I was the only one of the three that was really a percussionist. So when I would play, people would come up to me and say, where can I get one of these things? And I would direct them to Max and Tom. But the problem was that what I was doing was really different. Yeah. So really, the truth is it has sort of been sitting, I wouldn't say stagnant, but no one else has picked it up. Now that I have one that I think I can make for a couple $100, that could change. I'm sure. Especially if I went to, like, you know, the Percussive Arts Society. I've never, ever gone into that world at all. I've only been in our world. And also a little bit into the, you know, the Cuban jazz thing. But even when I play Cuban jazz, it's so unusual. It's not, you know. So anyway, yeah, I would say that the time is ripe for some new instruments. I mean, what's his name? John Worthington? He was here for a while. He has this djembe thing. Nothing like this, but the point is, it's a commercial instrument that I assume. Has anyone seen that instrument? Yeah. Is it pretty good?
Yeah, twice with it.
He's been working hard on it, I know that, yeah. And he's a smart guy. I mean, I'd be curious to see what he did. It's more of a hand drum. The point is, there's a lot of people who either play drums or want to play drums, you know. So yeah, and I'm not interested in big commercial success or anything, but I do think that this instrument could be out there. And what I might do is what Randy did, which is sort of open source, so people can do your own sort of thing, but then make a really good one that people would buy. Maybe I would do that. I'm not too good at that business thing, but...
Do you know how many that Max made before he died? He was putting them out commercially too for
he was.
a couple hundred, right?
Probably a couple hundred. I mean, Chris would have a better idea than me. I would say over the entire time they were doing it, at the most 200, probably more like 100. What do you think? Or even less?
I talked to Tom when I interviewed Tom Oberheim about the radio.
What did he say?
It was like close to 100. It was
100, yeah.
It was close to 100.
And that's all the versions, right?
Yeah.
Yeah. Oh, one other thing I wanted to mention, just sort of funny. About 2 years ago, I got a call from the New York Historical Museum. There's a museum in New York City. And they were doing an exhibit called, I thought it was in my slides, but I missed it. Anyway, it was called, you know, Electronic Arts in New York or something. And they were highlighting Max's work and other people from Bell Labs. And they wanted the original radiodrum. So they got in touch with you guys, I think, and no one could find one. And so then they asked Ron Quivola, and he said, well, you should talk to Schloss. He never throws anything away. And sure enough, I had one. And then they sent these guys out. It's so funny because, you know, this was an art object going to a museum in New York City. So they sent these guys who are normally moving Picassos. And they came in, I had just this piece of metal, right? And they had their gloves and they put it in this huge box. It probably cost $5,000 to send it to New York and back. And it's not even usable. Anyway, it was in that museum for about a year. But so 100 over all these years.
You had one installed at some Singapore Science Center for
really?
6 months or so.
Is that right? Yeah, yeah. So, I mean, you know, it was, I think Max was brilliant and he had his approach to it, and I think it never was that commercial because, well, for a lot of reasons. But one thing is, if you were a percussionist, it was not the thing you wanted, you know. It was more of a conducting device, really. And so when I went to Max with my problems, he was very nice to me, but he also, implicit was kind of like, it works for me, kind of like, you know. And so I really struggled to make it better. And so anyway, now I'm finally, actually after all these years, I'm finally have a whole new version of it. So I'm hoping that it'll develop faster. But is Tom's not still making them, is he? Anybody know?
No, he's not making them.
Okay.
Yeah.
Uh-huh.
Yeah, I've been working with him to try to get some of the codes so that other people could use it.
Yeah, well, I'll send you, yeah. Question? Yeah.
Yes, so with your new project, your new drum, do you envision it ever being used for the conducting program?
It could be used for the conducting. Sure, it could, absolutely.
And then it would work with Max?
It would, yeah. Mm-hmm. There'd be a little bit of software, you know, to make it talk to it, but yeah, sure. You could do all the stuff that Max used to do with it, yeah. And that would be nice too, to keep that going, yeah.
Except Max is like, his whole thing was that he would take a MIDI file and mark it.
Right.
And so the interesting thing is that, like, it wasn't that he was playing notes. He was,
Right.
It was the conducting part was the software part.
Exactly, right.
Next event, next event,
Right,
next event.
right. That's why I said earlier that he really anticipated the entire Guitar Hero thing. Not that that was his interest at all, but he did. He anticipated that by making something, by basically controlling which parameters you want or need to play, which is really interesting. And I do that too. Like with David, there are plenty of parts in the pieces where David has written some music that's in memory, just like the sequential drum, and then I'm controlling some other aspect of it, and when I hit it, I never play a wrong note because it's, you know, it's in memory. So that is still a useful idea for sure. Yeah.
What's your point about the, you know, the same intent? I think maybe it was more explicit than you remember, because he always talked about active listening.
Right.
It's a little bit like Guitar Hero. I mean,
Right.
You're part of the playback.
Right. I see what you mean. Yeah.
And, a couple hours ago, I was just remembering with somebody like Max totally imagined self-driving cars because he wanted one so bad, and that was like 1985.
It's amazing.
Yeah.
It's amazing. Yeah.
He said, "Why isn't it done yet?" I don't get it.
Yeah. Come on, let's get with the program. Yeah.
Have you ever tried not a flat surface, but something that's like bowl-shaped or some other different?
I've never tried that just because, you know, the antenna is a big printed circuit, so I've never tried bending it, or making it some other shape. I mean, you could do it, I guess, somehow. I'm sure you could do it, yeah.
Yeah, I had a question along those lines, actually, which is to really make it more 3D.
Right.
I mean, it changes everything.
Right.
It changes the percussion practice, but it would also take care of the lack of resolution.
Right.
Introduce all the problems. It's a whole new space.
Or something like a steel drum with different panels, zones that are more physically.
Right. You could certainly combine it with other physical instruments and things like that. There's also magnetic sensors, which I've looked into. I found one that looked interesting, but it was $60,000. So I went back. The funny thing is I called them and said, I'm doing research on art and stuff. And they said, oh, that's great. We're going to give you a special price. And so instead of $68,000, it was $60,000. So it didn't really help.
Hey, with all the 3D printing whizzes around, has anybody looked at making the antenna that way?
No one has. That would be cool. Yeah. Well, I will send you what I know about where I am with all this, and if anyone's curious. I mean, I do have the schematics for this drum, which is very hard to duplicate, but then I also have the simple version here, this one. So yeah, I'm happy to send that out. So there we have it. Thanks for coming. Yeah. So, yeah.